Hello everyone. This tutorial is an introduction to Stratos, the hybrid cloud management solution. My name is Louis Paul. I'm a cloud solution architect at SUSE, and I will be presenting you our nice product called Stratos, which is the view to inside a few of our application delivery solutions at SUSE. So what is Cloud Application Platform, and what is the need for Stratos in that framework? The Cloud Application Platform is a solution from SUSE that helps accelerate innovation so that developers and people in application development in general can accelerate their delivery to market. What do developers do? They want to get their apps in the clouds in minutes, and they don't want to really care about how difficult it is to get it there. They just want to be able to deploy the apps and have it running in hybrid environments. So let's get the developers to focus on the code and let the platform do the rest to deploy this at scale. So Cloud Application Platform is a code-centric platform. What that means is it helps reduce the application cycles by taking a lot of the time that developers usually spend in trying to prepare the applications in order to deploy to the platform, from things like days, months, down to minutes, if possible, depending on the environment that you're running from. It is a prevailing open source application platform. If you look at our competitors, you'll see that there's a lot of solutions out there, but not all of them are open source. With SUSE, you get a complete operating system down to the stack for the applications that is all open source code, and you can both contribute to it and ensure that over the years you'll be able to use this platform without any locking, any vendor locking. Foundry itself has been used by a lot of Fortune 500 companies. It's a proven technology. It's been there for several years. You can go to cloudfoundry.org and see a list of enterprises that are using the technology successfully today. So let's go and make it easier for developers to build things and deploy using Cloud Foundry. What we found out for having a successful application platform is that we need to have good tools that are available to developers right on time so that they can get their job done. And you also have to have tools for the operators to be able to handle the workloads that the application developers are sending out to them. So quite often those two tools are not identical. There are a set of tools that are used for automations that are used by operators. There's a set of tools that are used by development teams that are just for getting the code built and then getting it prepared to be deployed. But is that tool set sufficient? And we think not. And I think there's an opportunity here for us to improve on the tooling so that those two worlds of operators and developers can get together in one consistent platform. So Cloud Foundry has given us the benefit of having a standard API, and developers like APIs because they like to be able to do everything as code. So having a CLI that is behind those APIs allows the developers to do very quick scripting, which is very useful once they are in their environment, that means on command lines usually, or in an IDE, or within the realm of a CI/CD tool, continuous integration and continuous delivery tool. So they can track all the feature set that they need, and they can just invoke CLIs and invoke it with the parameters in order to activate those feature sets. One of the deficiencies of running CLIs, though, is that you need to get the client installation size done. It's not necessarily designed for browsing, so there are a lot of parameters to pass by, And when you're at your CLI, you don't usually think about all the options that you have to pass through your CLI. So you're always going back and forth between the documentation and your CLI. So you're losing a little bit of this productivity that you would normally get from doing something in a visual manner. So you also have to get the context in which you are trying to deploy the application. So in Cloud Foundry, there's a concept of organizations and spaces, and those are things, context that you have to navigate before you get to the point that you can actually deploy your application. And then there's the multi-cloud, multi-environment. So sometimes you're developing and deploying to one particular cloud. Sometimes you're developing and actually in one of the organization and spaces. Developers are sometimes switching from one project to another. They might be now developing new code for new projects, and then they get some bug request, and they have to go and switch to their older projects and go fix the code and then come back to their current project. So all this is fairly slow when you're using a CLI, and you have to keep context and which endpoint you're connected to and so on and so forth. And then once you're in a CLI, it's very hard to get insight into what is happening on the actual environment that you're running in. You're in a CLI, you're concentrated doing your neck action, you don't see what's going on when you're deploying, where the capacity is getting used, who else might be using resources. So all these are actually not very clear as you are staying in a Linux shell, for example. And of course, you don't see any aggregated views of the resources because you might be, when you're in a CLI, just in the context of one of the environments, so not in the context of all the environments that you are potentially working on. So you have to switch from one to the other and then run some other CLI commands in order to be able to get all the details about what is being consumed by different environments, where your application is, or they deployed successfully, are there any logs of errors while you're deploying, and so on. So Stratos was designed from the ground up to solve some of these problems. There was no standard way of doing management of applications across platforms like Cloud Foundry. So Stratos was built in order to provide this ease of use through a web interface to be able to do what you would have done traditionally via a CLI, but now run this concurrently within Windows panes and be able to switch context from one to another without having to disconnect and then remember things. So SUSE Cloud Stratos console runs on top of SUSE Cloud Application Platform. What that means is that we have the infrastructure that's set up by SUSE Cloud Application Platform. It's typically running on a Kubernetes cluster. And the Stratos Web Console is going to run within that same infrastructure. That will give it the ability to be able to use the same authentication mechanism and be able to leverage the same set of resources and also take advantage of the resiliency of the underlying platform that your application is also going to go on. A little bit of history about Stratos console. It was created by SUSE, open source in 2017, mid-2017, and it was accepted by Cloud Foundry as an incubating project. And shortly after that, there has been a lot of interest and contribution by the rest of the Cloud Foundry organization. And we finally graduated in 2019, and it has become now a first scale project at Cloud Foundry. It is the de facto UI, so there is, as you'll see later in this presentation, two flavors of Cloud Foundry Stratos. One of them, which is the upstream, that is default UI for the Cloud Foundry organization. And then there is a version that has look and feel and a few additional capabilities that tie together SUSE's products. It is very easy to use this UI to extend to use multi-cloud Kubernetes clusters. We will go through this in a demonstration at the end of this presentation. And we've, over time, added some functionality to be able to ease deployment of not just your applications, but the deployment of services that may already be available as packaged software via Helm chart repositories. This helps very much in terms of getting your services that you might use with your applications or other services that you might want to use in context of application development. For example, you could be installing a Helm chart for a continuous integration, continuous delivery tool like Jenkins via the Helm chart repositories, and then use this to actually build the rest of your pipeline for your application. After your application is deployed, you'll be able to visualize all the details that there are about your applications, its utilization, how much of the cluster is being used, where it resides, and where it's deployed on the nodes. And in addition to this, there is a feature in Stratos where you can use some auto-scaling rules in order to be able to manage how you want your application to scale over time. So this could be useful at end of month when you anticipate a lot of access to your applications and you want many instances of your application to run, or you might be watching and ensuring that you have an SLA that's appropriate for your application, and you want to manage the throughput response time of your application. All this is possible through the UI, and it's very intuitive to do it that way. You can also do some of this via the command line, as we've mentioned. It's all APIs that are used underneath the covers. It's just more difficult to be able to do this via the API without constantly going back and forth between your CLI and documentation. And you might get some things wrong. No validation sometimes happening until you type no commands. So there are different personas that are going to be using the Stratos console. So we're going to go through a few of them. Again, during the presentation later on the demo, we would be able to show a little bit of this in action. But this is not a exhaustive list, but these are the main things that you would do depending on the role that you have for using the Stratos console. So we will start with the administrator role. So the first thing that you want to do as an administrator is to set up an environment for your developers to be able to consume the resources and also to be able to deploy the applications and view all the workloads that they need in order to run this application successfully. So your first order of business is going to be connecting to an existing SUSE Cloud Application Platform. There is a pane within the SUSE Stratos console to be able to actually register those endpoints. It takes a few clicks. You type on the endpoint URL, and then you can name those endpoints as you see fit in a meaningful manner, especially if you have many of them running. You might name them with something that will be recognized both by yourself, the administrator, and also by your users. Once you have the endpoint registered with Stratos, immediately you will see on the left-hand side pane that you will have one of the Stratos clusters that is now in your purview so that you can go and browse through this cluster and then be able to look at all the artifacts that are within this cluster. One of your main order of business there is to be able to go and start making this cluster a multi-tenant environment that is usable by multiple development teams within your organization. So you will go there and start creating organization and spaces. And in order to be able to control that nobody just runs all the applications and makes the whole environment run out of resources, you can set quotas and app limits to these environments. Now that you have your environment set up, you can now use the rest of the capabilities and features of the cloud application platform to see all the inventing that has happened. So, for example, the creation of your orgs and spaces, your creation of quotas, all these are going to be registered in event logs. And you'll be able to go and refer to those logs over time to know who has done what on the environment. Applications are great. Your developers are now going to be able to deploy them and start presenting those applications to the teams to be able to review the apps and then test them, and eventually to your customers. But quite often applications by themselves are not sufficient. Applications need to consume some services such as databases or endpoints that have some streaming of data that is necessary to be able to populate the views in the applications. So one of the tasks for an administrator is also to register what's called open service broker services together with the platform. That's easily done through the UI, and you can also back it up by doing some other fine adjustments to those services via the CLI when needed. So the Stratos console provides you a way to actually browse and search through the service catalog. So that's as soon as you have services that are registered with the cloud application platform, they become visible in Stratos UI, and you can go and look at the marketplace of these services and pick and choose the services depending on service plans or costs or the versioning of those services. Once you found the services that you want to use, if you want to test this as an administrator, you can actually bind these services to an application and see that it connects to it successfully. And that is now ready for developers to be able to start consuming those services from the applications. Now, we talked a lot about SUSE Cloud Application Platform providing you a single pane of glass across your Cloud Foundry clusters. SUSE Cloud Application Platform actually can do more than just Kubernetes, than Cloud Foundry clusters. You can actually register Kubernetes clusters as well, and you can use these clusters as endpoints to deploy additional workloads. One of the things that you can deploy directly to the Kubernetes clusters are services and applications for which you have Helm charts that you can register and then deploy from. So as an administrator, same as you have registered either a CF endpoint or you have registered an application, a Kubernetes cluster, you have the options to actually register the Helm chart repositories, view those repositories, and then if you wanted to test these, you can actually deploy the Helm charts and decide which cluster you want to deploy these Helm charts to. And once they are deployed to those clusters, then you would be able to make those workloads available to your applications. So you can view all these Kubernetes artifacts and Cloud Foundry artifacts from the console once all this is done. And there's, of course, a lot more that you can do with this platform. So this was a summary of the administrator's activities. Let's now move over to the developers. The administrator has done his job. He has made the cluster available to the developers, and now it's time for the developers to go and start looking at how they want to manage the applications. If applications are already running, that means they are working in a team and they have started deploying applications, you can, developer in the right role would be able to start viewing those applications. You can scale these applications. You can manage the life cycle of it, which means you can start, stop, restage the applications. There are several ways for the developers to deploy the applications. They can not only deploy it as the Cloud Foundry applications, but they can also deploy it as a Docker container. And once those applications are deployed, they can SSH to the application container and be able to look at the logs, be able to look at the process running. This is mostly for debugging reasons during development time. Anything that is happening within the platform is streaming logs that are immediately available for the console, so that is very useful for developers. They can always go back to those logs over time and look at any instance of errors or any instance of deployment that has happened. These logs can be archived or can be forwarded to a log aggregation server, which also means that you can look back and then parse this data by date, by hour, by minute if necessary, both for debugging purposes, for forensics reasons, auditing reasons. Once you have your application running, there's a slew of other things that you can do. You can watch how the application is behaving over time, look at the metrics consumed by the applications. You can look at the services it's connected to. You can look at any type of performance through metrics that is captured with from the platform and displayed. So there's quite a bit of details that the application developer can do here. And this is available to the developer both as details that are Cloud Foundry and also if workloads are deployed as Helm charts that are deployed directly to the Kubernetes cluster, they would be able to view those resources and metrics as well. One of the other roles that there is that is not very commonly used is the user role. What that means is the developer, of course, can manage and do a lot more with applications, but you can actually be authenticated to the console and be able to look at applications and launch them. And this could be applications that have been developed and deployed by someone else, but now you have a single pane of glass, and that user could be someone like a tester, for example, or it could be someone like an auditor that wants to know what are all the applications that are existing in a certain organization, in a department, and they might want to look at that. And given some roles, you might also give the ability to that user to be able to manage the life cycle. That means to stop the applications. So that's an additional role. It's a subset of the developer role, but can be refined with the right role-based access controls. In addition to just looking at the applications, the user might be looking at a few of the deployed services in the marketplace. So over time, development teams might get very sophisticated and not just deploy discrete applications, but deploy a suite of applications that could be used by multiple users. And these could be made available through the marketplace and could be browsed by the user and then look at things like the service plan, the cost of running these, and so on and so forth. I will now switch over from the personas that are using this more to a problem that we've encountered today with a lot of our partners and our customers. And this is finding a solution that can support managing multiple instances of the application platform across multiple clouds. So some of the solutions that exist today are very good at managing things that are running locally on premise, and they use a certain set of technologies and they have a certain interface to it. And then there's other solutions that are built for the cloud, and they are made available directly on cloud solutions, like service providers. What if you had both? What if you wanted to switch between running things on premise and you wanted to run things that are in the cloud? And what do you want? What if you want that experience to be the same? You don't want to switch tools. You don't want to switch what you've learned to be able to deploy and manage your applications locally because it has changed on one of the cloud providers. And when you go from one cloud provider to another, you won't change tools either. So this is one of the big benefits of using the SUSE Stratos as a tool to unify those environments together via a single pane of glass. What Stratos does very well out of the box is to be able to do this for all your Cloud Foundry instances. And by the way, the Cloud Foundry instances could be instances that are running from multiple Cloud Foundry implementations. So we pride ourselves on having one of the best of breed Cloud Foundry implementations, but they are out there. We realize that there are the upstream Cloud Foundry clusters that run. And we also know that we have other vendors that will support Cloud Foundry compliant implementations. And with the Stratos console, you can actually go and connect and deploy to all of them. So just using a standard API will permit you to be able to go and start connecting to all of them and start seeing all the data that is necessary to be able to manage them and context switch between them. Well, we achieve a lot of the things with Cloud Foundry by actually designing it properly and thinking of the future. So the Stratos console actually are using very modern techniques to be able to implement this. The front end is using Angular 8, and the back end is written in Go. So this architecture provides us an ability to be able to both scale and also to be able to extend this framework to be able to, over time, have other type of endpoints that we want to manage. I will be relatively brief on this. This would take a whole topic by itself, talk about extension of Stratos, but just to give you some ideas so that you can contact SUSE and have more discussion, is how we have engineered the product to be able to authenticate with different APIs throughout different endpoints and keep metadata about these APIs so they can be different from something like Cloud Foundry or something like Kubernetes or a metrics endpoint or something that is managing Helm charts. But we're keeping a lot of the details that we have in a common authentication server called the User Authentication Authorization Server. So we keep this together, but we can actually authenticate with different endpoints. And this can be extended to any type of endpoints that has an API to authenticate. And there's more to do in the extensibility, but already Stratos has been designed to be extensible, not only with the development frameworks that are used underneath the covers, but also the components that we plug in so that you can switch your authentication provider depending on what you want to connect to. And you can also switch custom APIs in the back end on how to render different components of the views that you want. They are all using very modern and is very pluggable. If you're interested in the extensibility, I suggest you contact SUSE and we can talk to your development teams on how they could extend this backend and also change the front end to customize it for your own organization's use. So here's a few list of things that you can do with the using the extensibility that exists today. And these are going to be things that are going to be very developer-centric. So for an introduction, this is potentially a little bit out of scope, but this is a list of things that you can browse through. And as I mentioned, please contact SUSE if you want to look at doing more extensions to the Stratos console over time. A quick view of how easy it is to add using those frameworks, any new components. This is a view of how to add a new tab, for example. And then what is the endpoint that is being called when you select those tabs. Okay, so now we're back to Cloud Application Platform. Just before we go and start doing a quick demo, there are a few things that will be very important for you to understand about the platform. And this is a very high-level architecture. And the demo will just confirm a lot of these things. So this is just some stack diagrams that indicate what we run on top of. So earlier we talked about Stratos console running on top of SUSE Cloud Application Platform. And SUSE Cloud Application Platform itself runs on multi-cloud and on-premise on a Kubernetes cluster. Kubernetes cluster is just a compliant Kubernetes cluster from CSCF. Any of them works with our Cloud Application Platform. Once you have your Kubernetes cluster, you can also be deploying some continuous workload on top of this. So you can have side-by-side both the workloads of our Cloud Foundry and also workloads that are running directly on Kubernetes. And this will become more visible as we go through the demo and show the drill down into the clusters and what's running where. And last but not least, any of these Kubernetes implementations are the ones that are supported today by SUSE. We also support other clusters outside Microsoft Azure AKS or Amazon EKS, Google GKE, and our own distro of Kubernetes called SUSE Cloud Containers as a Service Platform. So if you're interested in anything that is not on that list, please contact us and we will gladly walk you through how we certify on other Kubernetes implementation. In general, as long as you have a service support with your Kubernetes provider and they pass a few tests, you should be able to run we should be able to run Cloud Application Platform on that Kubernetes instance. Okay. So again, to end up here, we can easily extend this platform. We just showed you that with the different roles that we have, we can run the type of workloads that are both Cloud Foundry and also Kubernetes workloads. We also showed you that there is ways to extend so that they can be Helm workloads that are running, as well as we can add more extensions to Stratos so that you can point to another endpoint and consume views into the Stratos console. So we started, as we said, with Cloud Foundry historically, and then we extended to add Cloud Foundry running on multiple of these Kubernetes clusters, provided ways to be able to connect to them, and over time we started adding even more endpoints. That means not just Kubernetes clusters and Cloud Foundry endpoints, but also to be able to go and have metrics through Prometheus being consumed on Stratos and correlated with application workloads, as well as Helm repositories to bring in even more richness of services into your purview. So Prometheus is what was added in after we did the Cloud Foundry and Kubernetes endpoints, and brings both the CF exporter, which is metrics around Cloud Foundry, as well as the Kube node exporter, which would be the metrics around Kubernetes. And all these are correlated in the views to give you instant view of CPU, disk, memory usage, aggregated views, drill down from nodes to pods on what is using what. And helps a lot into debugging if you have some performance issues. The Helm repo integration adds some frameworks developed by Monocular project so that you can go and browse all the Helm repositories, see the details of what you would need to deploy. If the chart that is behind those repositories. I'll put metadata. We show you the metadata and we provide you a few forms to be able to actually deploy and override the Helm values if necessary during the deployment. Okay, so to recap, Cloud Foundry, we have provided Stratos console to be able to initially drill down through Cloud Foundry management of clusters, and also extended it for Kubernetes and for Helm repositories. And we have two flavors of our Stratos console, one which is meant to be upstream, consumed by upstream Cloud Foundry organizations, and then one that is built for purpose for SUSE and adds a few of not just the branding and the UI, but also things like support for SUSE Linux Enterprise images and other things that make it possible for us to support enterprises end-to-end. These are the different look and feels, and as we go through the demo, we'll go rapidly through both of these UIs to give you a view. So thank you very much. We will follow with the demo now, and thanks for joining us and looking at our solution for Cloud Foundry and Kubernetes, and we look forward for you to be a customer and user of these tools. If you have any questions, this is going to be possible to send information to SUSE, and then we will get back to you promptly and reply. Thanks again for attending the virtual SUSECON conference, and thank you so much for your time watching this presentation.